Over the last couple days, we've talked about equations that look like this, right? Tell me what kind of equation this is. Exponential, good, okay. So we have y equals ab to the x, which is our standard form in our exponential, right? Sometimes we're allowed to have something that looks like that. We just know that our a value is 1. Perfect, okay? But for the most part, we have a number here, and we have a base number here, right? Now, this is standard form, okay? We need to be able to put standard form into a recursive model. Now, I want to make sure that you understand something. I'm not giving you permission to curse again, okay? That's not what recursive means. Not at all, okay? Not recursive, all right? Recursive is just a different type of equation, different kind of function that you can do when you're talking about equations or functions, specifically right now for exponential, okay? A recursive model looks a little different. I'm going to turn this paper over real quick and write some for you. Usually you know like your zero term. Sometimes you know your first term, like 7. And then it'll say f of n equals f of 0 plus f of 1. No, it won't. It'll say f of, what am I trying to say? F of n minus 1. Is that what I want to say? No, that's not exactly right either. There's something close to that, okay?
What kind of 7
but
is that?
This, don't judge my 7. Or maybe this might just say like 5 plus f of n minus 1. Because what's f of n? What does that mean? Well, what if I was trying to find the second term? Guess what would go in for n? 2. Exactly right. Okay? So if I'm trying to find f of 2, that would equal 5 plus f of n minus 1. Well, what's 2 minus 1? Does anyone know what 2 minus 1 is? Okay, f of 1. So f of 1. Well, do we know f of 1? Yeah, it gave us that information in the beginning, right? So f of 2 would actually equal 5 plus 7, which is 12. So recursive functions are another way to write a function where, in this case, you have to know the term before the one you need. I need f of 2, so I need the term before it, which in this case is f of 1, right? If this was f of 12, I would need to know f of 11, right? The term right before it, okay? So let's talk about writing this equation right here, this exponential equation that's in standard form, into recursive form, okay? Well, for exponential, we have to know a couple things. We need to know f of 0, and then you need to be able to fill in this formula. F of n equals r times f of n minus 1. Well, why do we have an r times something? A couple days ago, we talked about what this particular r means. Remember? Ratio, right? Now, I know yesterday we talked about a different kind of r, and that r was for a percentage rate, right? That was a decimal that we converted into a percentage, and we're going to work on some of those today as well. But for right now, this particular r is our ratio. Remember when we did the tables worksheet and we had to find a common ratio on our table? Okay? That's the ratio that's going right here. But if we think back to that worksheet, is anything ringing a bell over here on this side about the r? Wasn't the r in this formula somewhere? Do you need to look back at the worksheet? You can. God bless you. Look back at your worksheet. God bless you. Look back at your worksheet. Something about tables and spending money. You remember that? What was it called? What's it called? Using tables and spending money. Okay? If we had an equation like this, was our r somewhere in the equation? Our ratio. It is, right? Where is it? Yeah, it's our base, isn't it? Okay? Our base is our r value. Our base is our r value, okay? All we need to know then is f of 0. How do we find f of 0? Well, what used to be here? Used to be an x. What do I want there now? A 0. So what is 1.44 raised to the 0 power? 1. Because anything raised to the 0 power is 1. What is 1 times 8.32? So for this particular problem, our f of 0 is 8.32. Now, is that always going to be this particular term right here? Is that always going to be our f of 0? No. To find f of 0, I'm always going to put a 0 up here, which will always make this term 1. Will this always be our f of 0? Because will I always multiply that by 1? Oh, yeah. Yes, it will. Okay? So I have my f of 0, I have my r. Do I need anything else to fill this out? So all I have left to do is write f of n equals r. So in this case, it's 1.44 times f of n minus 1. The only thing you have left to do to finish this problem is put a box around your answer. That is hardest part, yes. See, I even messed up. Yeah. Okay. I mean, I guess I could like that.
Yes.
Box.
Thank you.
All right. Now, is that easy? Yeah. We look here for the f of 0. We look here for the r. But at f of 0, we have to define our 0 term. And then we have to have our f of n term. So if I was trying to find f of 7, 7 would go here, and 7 would go here. So I'd have to know my 6th term, which I could multiply by my ratio to get to my 7th term. Does that make sense? Okay? So there's 8 or 9 problems on your homework that are like this. And then the first 4 problems, the first page, is word problems like the stuff we did yesterday. Remember yesterday we learned how to do it? Today is when we get to work on the why. So today you'll work through, I know there's words, so you're just going to have to be patient with yourself. Read the words. Okay? The problems in the book go very slowly for you. Like the first problem, the first letter A on the first problem says, is it growth or decay? Can you tell now by looking at an equation if it's growth or decay? Yes. If that parentheses is the base, if it's greater than 1, it's what? Growth. If it's less than 1 and greater than 0, it's decay. You got it? Any questions?